Hi, this is Adam Griffin with the ninth week of physics videos. So this is going to be problem 40, and it is a 50 kilogram sprinter starting from rest runs 50 meters in 7 seconds at constant acceleration. So for part A, we have to find the magnitude of the horizontal force acting on the sprinter. And for part B, we have to figure out the sprinter's power output at 2 seconds, 4 seconds, and 6 seconds. So here we have a little diagram showing what is happening and all of the parameters. So we have our 50 kilogram sprinter. I'll switch to this cursor. 50 kilogram sprinter. The force acting on them horizontally. Our 7 seconds to go from the start to the finish. And then the distance, which is 50 meters. So to find this, the force, we know that force is equal to mass times acceleration. So we'll be using that. So to find our average velocity, all we have to do is divide the distance by the amount of time that it takes. And we get 7.14 meters per second. So that is our average velocity. And since it's at constant acceleration, we know that that is going to be the halfway point between the two values. So if our starting velocity is 0 meters per second, and we know that our average is our initial velocity plus our final velocity over 2, we can calculate that, and we find that our final velocity is 14.29 meters per second. So using that, we can find our acceleration. So we take our change in velocity and our change in time, and we divide that, and we get 2.04 meters per second squared. So now that we have acceleration and we have mass, we can figure out the force. So we just multiply these two together, the acceleration and our 50 kilograms. We get 102 newtons for the force acting horizontally on the sprinter. So now for part B, we want to know the sprinter's power output, and power is the rate at which work is done. So we have that right here, where power equals the derivative of work, and we know that the partial derivative of work equals force times our change in difference, or change in distance, sorry. And we can divide both sides by dt to get that our dw over dt equals our force times ds dt. So we have our ds dt up here, and actually that is going to change because we're using a different amount of time. But we can plug this in, so we get that power equals force times our rate of change, which is velocity. So we can model velocity as acceleration times time, because acceleration equals the derivative of velocity. So if we integrate that, we get v equals at. So if we plug all of this in, we have power equals force times acceleration times time. We plug that in for all 3 times. So at 2 seconds, it will be 416.3 Newton meters per second. At 4 seconds, it'll be 832.7 Newton meters per second. And at 6 seconds, it'll be 1,249 Newton meters per second. So this problem relates to obviously force as well as work and power, because we're having to solve for all of that to find our final answer. And yeah, so that is how you do problem 40, and thank you.